Hello grade 2! Welcome to our first video math lesson. Today we're going to be continuing to look at subtraction strategies. Okay? Now, you're probably looking at the board and going, Mr. Brabant, this looks really easy. And you're probably right, this is probably a really easy one. But we're going to start off easy and we're going to get a little bit harder. Now, think to yourself, what does this show you on the board? Yeah, maybe you said, hey, what this is showing me right now, it shows me 3 plus 4. Good job, you might have said that. You also might have said, well, I've got 7 and I'm going to take away 3. And that comes to 4. And you also might have said, well, Mr. Brabant, that shows 4 plus 3 equals 7. Or you might have also said, well, actually, no, Mr. Brabant, I think it shows 7 minus 4. Take those 4 away, leaves us with those 3, equals 3. And you're absolutely right. If you said any of these, you're right. Not a hard question, something you've done in preschool grade 1. Yeah? Now, we've also looked at what this can mean using number bonds. We looked at number bonds early in the year. We said, okay, so we've got our big number is 7, put it in the top of the number bond. Down below, we have the 2 add-ons. So we have 3 and we have 4, so 2 add-ins there. And you learn the relationship that 3 plus 4 equals 7. Or 7 minus 4 equals 3. Or 7 minus 3 equals 4. All of those are correct. Now, why are we looking at this? Well, we're looking at this to see the relationship between the numbers. There is a relationship between all the numbers. That here we see that plus and minus, we know that addition and subtraction are opposites. If you do one, then you can look at it the other way, and that's what we're going to look at right now. Okay, you might be wondering, wait, it all just disappeared. You're right, it did. So now, what often happens when we're doing math is we use a manipulative. We use something that we can see that we can use to help us with the problem. Here we have these manipulatives, these nice colored magnets. Now we don't always have these things, and as we go through, it gets easier to do things in your head. So if we have this question, a subtraction question of 7 minus 4. Easy, right? One thing you can do is just look at this and we say, take these off, we know the answer is 3. But let's just, for the sake of argument, say, let's not do that. We're going to do another way. Another way people do subtraction is by counting backwards. So if you start here, this is number 7, and go backwards, we go 6, 5, 4. So we've taken away these 4, and then the remainder is 3. So we take those 4 away, we get to 3. That's the way of counting backwards. You can also, instead of just counting backwards, what we can do is we can actually count forwards. Like what? So the way we count forwards is if we were to count the other way, we start at, okay, we have 7 and 4, and we count from the 4th one, so 1, 2, 3, 4, and then we count up to 7 from number 4, so 5, 6, 7. So that's 3 there. So it works either way. You can count backwards, or we can count forwards to get to the same answer. Because what we're really doing with subtraction is we are looking at the difference between the two numbers. And often in a math question, for subtraction, it will say, find the difference. So we're looking at the different starting and ending points for a subtraction problem. All right, so our numbers have disappeared again. No manipulatives, because, well, we want to be able to do this without those manipulatives. But there's one manipulative that we have, that we always have with us. It's our fingers, okay? And it's okay to still use your fingers to count back and forth. So take a look at this question right here, 16 minus 7. The one way to do it is to count backwards. So we start at 16 with a closed fist, and 15, 14, 13, 12, 11, 10, 9. So I've counted back 7, and the answer I got to here was 9. So 16 minus 7 is 9. Now, the other way I could have done that is instead of counting backwards, because sometimes counting backwards can be a bit confusing, it's easier, as with most things, just like walking forward is much easier and safer than walking backwards. So if we count forwards, because we're looking at the difference between these two numbers, between 7 and 16. So we don't always have to count backwards, we can count forwards from the smaller number up to the bigger number. So same idea, we start with 7, the number we're starting at with closed hand, and then we count up to 16. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And if you count my fingers, I've got 9 up, yeah? So it gets us to the same answer whether we count forwards or backwards, okay? So the answer is still 9. Now you're probably still thinking, Mr. Bradman, this is really easy. I don't need to count on my fingers to get there. And that is great if you don't. But it's going to help you later on, okay? Let's check out the next step. Oh, this time I'm going to let you watch me erase it. Okay, so here we go. Now, from that, we're going to go into a little bit bigger numbers, okay? Get a little bit more higher numbers. So we're going to go with something like, say, I don't know, 43 minus 36. Yeah, and many of you, I know, you've got it in your head already. But for those that don't, the same strategy works. We can count backwards from 43, right, until we get to 36 and see what the difference is. Right, so again, fist, 43, 42, 41, 40, 39, 38, 37, 36. So we've stopped at 36, and the difference is 7. Now, as we said before, I could have done it going forward, which is, like we said with walking, easier going forward than backwards. So I want to find the difference from 36 up to 43. Okay, so I can start, same thing, closed fist, 36, 37, 38, 39, 40, 41, 42, 43. And I still end up with the same number on my fingers, 7, okay? Now, where is this going? Because that's still quite easy, yeah? If we jump to bigger numbers than that, because these are still numbers we can count on our fingers. But eventually, we get subtraction questions that we can't count the difference on our fingers. For example, 70 minus 28. Yeah? If I'm going to try and count on my fingers backwards from 70 to 28, I just don't have enough fingers. Same thing. I could count from 28 up to 70. Either way, I still don't have enough fingers to get there. So, what can I do? All right, we're going to keep looking at this question, and you're probably like, whoa, the lighting has changed, or something's going. Yeah, I tried to make it a little bit clearer for you to see here. And I tried to write it a little bit neater as well. We're going to take a look at this. So 70 minus 28. Yeah? One thing we know is we can't count this on our fingers. But we can think, okay, well, there are some big numbers that we can, in a way, count on our fingers. So if I took a number like, let's say, 70 minus 40. We know that 70 minus 40 is just like doing 7 minus 4. The zeros cancel each other out. Yeah? And I can do 7 minus 4 on my fingers. Okay? 7, 6, 5, 4. Oh, it answers 3. Or I can count up from 4 to 7, going 4, 5, 6, 7, 3. Okay? The same thing with the tens. I can count by tens with my fingers if I really need to, going up or down. So we'll go down first from 70 to 40. So 70, 60, 50, 40. That's 3, and we know we're counting by tens, so 3 tens is 30. We could do it the opposite way as well. We could go, okay, I'm going to count forwards instead of backwards. So 40, 50, 60, 70. Again, gives us 3 tens, gives us 30. So we know that counting by tens and counting by ones are basically the same thing. Now, how does that relate to this bigger question of 70 minus 28? Let's take a look. Now, the other day, we kind of talked about a strategy of number lines. Okay? We know how to count on a number line. Now, my number line does not have to be a number line where I start at 0 and I go all the way up to my big number of 70. It doesn't have to be that way. We're going to use what we call an infinite number line. With the arrow on the end means this just keeps going. On the other way too, just keeps going. And I can start my numbers anywhere on this number line. So I'm going to put the two numbers that I know. Okay? And I want to look at my big number, so my 70 is going to be over here on this side. My smaller number can be down here at 28. Now, doesn't mean because it's here it's at 0. No, it's just that's where it starts. It starts at 28. This line says this keeps going down to 0. How do I use a number line? Well, I know that counting by tens is really easy. So I want to go from this number of 28 to the next 10. So if we add on ones, 29, 30. 30 is our next 10. Then I want to go from my 30 to my 70. And now, instead of having to count by ones, we can count by 10. So 30, 40, 50, 60, 70. It gets us there. Now, the quick way to look at it is go, okay, so I had here, I count my ones between 28 and 30. Easy to count, there's 2 little humps. So my number here is 2. Then I count my tens, 10, 20, 30, 40. I see 4 humps, so this is 40. So again, I've counted upwards from my smaller number. That's one of the reasons instead of counting backwards, we could do the same thing going backwards, but as we said before, it's easier going forwards. So 2 plus 40 equals 42. Easy to add those two numbers up. So we know now the answer 70 minus 28 is 42. All right, so we've looked at that one way. Well, we can look at this in another way. We can say, okay, well, we have the 70 and the 28, and we know 70 minus 28 is almost the same thing as saying 70 minus 30, right? But that's only one part. We don't have the other part with the 28. So we can also, okay, well, it's the same thing, 70 minus 30, and then 30 minus 28. We can break it up this way too. Now you're probably a little bit confused going, well, why is there 30 and 30 here? Think about that. Why did I put another 30 in there? Any idea? Well, if you said minus 30 and plus 30, they really, minus 30 and plus 30 equals 0. So it's the same thing right here as 70 minus 28. But trying to do 70 minus 28 is a little bit difficult. So we just keep it the way it was here with 70 minus 30 plus 30 minus 28. And we look at the two bits separately. So, okay, 70 minus 30 is 40 plus, we carry that plus down here, 30 minus 28, easy enough, that's 2. It's the same thing we did up here with the number line. So 40 plus 2 equals 40. All right, yeah, I just disappeared for a second. What actually happened was Miss Brabant called me and I got kind of interrupted and then it stopped the video and then I just kind of poof, disappeared. But I'm back and I'm going to continue just from there. So we were just looking at the answer right here. fix the camera a little bit. So we say, yeah, it's the same thing here as 40 plus 2 is 42, which is the same answer we got up there. Now, let's take a look at one more example, and then we're going to be done for the lesson part for today. Again, here we go. Again, we'll look at a bigger number. We'll go with something like 93 minus 67. Okay, so again, we can use our number line strategy to get us there. So we've got the number line. Again, our big number, we can even start with a small number, put the small number down here. All right, 67. We get our big number. Okay, we're looking at the difference between these two numbers, 93 and 67. Starting at our small number, okay, we go, okay, I want to go to the next 10, which is, let me hear you say it, it's number, right, 7, okay, so 67, 68, 69, 70, let's mark that there, 70. Then we're going to go up to here. Now, if I go from 70, and I want to get to 93, my closest 10 to this one, before I get there, is going to be 90, right? So I'm going to go from 70 to 90, and I know that there's one 10 here, that's 80, and then to 90. So we've got our two 10s, and then we count up. So 90, 91, 92, and gets us to 93. Now, I've got that written down. Now my strategy is, okay, I look at the difference here. There's 1, 2, 3. I'm going to add because I'm going this way. I've got 1 10, 2 10, so 20 there. And then here between 90 and 93 is 1, 2, 3 humps. So the difference is 3 there. So all together, we can easily add up. We'll add up our ones. We'll go 3 plus 3 is 6. 20 plus 6 equals 26, if that's what you said. Okay? 26. Now, there's another way to do this without a number line. Okay? Because, to be honest, if you're writing this out every time with the number line, it can take a bit of time. We want to get to the point where we're able to do this faster, able to do this in our heads. Okay? But as a strategy, writing on the number line, doing it just like this, is a great way of doing it because you have a model. You don't have to count all the ones between here, but it still gets you to the answer. Okay? So let's look at the same problem without the number line. So we're gonna take our question here, 93 minus 67. I'm just gonna draw a line here to try and make it look neater, separate. Now, same thing. We can organize our numbers kind of like we did in a number line, but without the number line. So again, going from lower number to higher number, we'll put our 67 there. We'll put our 93 here. And then we're going to say, okay, what are the numbers? What are key numbers that we had? We're looking at the 10. So 67, the next 10 is 70. And then we're looking at the next key number here, which is 90. So we're going to look at the numbers like so. Then we say, okay, we're looking at this to here to here. Okay? Now I could have put one more hop in here. I could put my 80 in here, but I think this is easy enough that we can just skip the 10 here. We go, okay, 67 to 70, that is, if we need to count on our fingers, 67, 68, 69, 73. And we're adding, and then we go, okay, 70 to 90, I know that's 2 10s, so that is 20. And then 90 to 93, 0 plus 3 is 3. Okay? And that gives us the numbers we need to add up. So again, 3 plus 20 is 23. 23 plus 3 more equals 26. So again, it brings us our answer up here to 26. So, I hope you enjoyed today's lesson. Hope it's useful for you. In your not your notebook, in the math pages I sent home with you, I would like you to complete pages 55, 56, and 57, practicing these techniques we looked at today. And also I will assign you one more later on to practice with these bigger numbers again. So that's all for today. Have fun with math.